Sphere, channels 8 to 15. Window size, a control for zooming in and out of the EEG data, with a default window size of 10 seconds. Detrend, a toggle to enable or disable trend removal from the EEG data. Filter order, a parameter to set the order of the filter, typically ranging from 1 to 5. Whole spectrum, a toggle to overlay the non-filtered spectrum, frequencies below 0.5 Hz and above 30 Hz. Frequency scale, an option to choose between linear and logarithmic frequency scales. Output display. Noise removal performance, displayed as signal-to-noise ratio, SNR, and mean square error, MSE, of the EEG signal. Raw signal, visualization of the EEG signal in the time domain. Spectrum, representation of the EEG signal in the frequency domain with the ability to view specific frequency bands, delta, theta, alpha, beta, whole spectrum, if selected, additional information. Users can observe changes within different frequency bands by selecting specific frequency ranges or by enabling the whole spectrum option. The application uses a wavelet-based noise removal algorithm, with options to customize its behavior. Users can interact with the EEG data by playing, scrolling through the file, and adjusting various parameters. This Flask application would serve as a user-friendly interface for analyzing EEG data, allowing researchers and practitioners to explore and manipulate the data in both the time and frequency domains while evaluating the effectiveness of noise removal techniques. The application would provide valuable insights into EEG signal processing and analysis. Welcome to the IEEG Spectrum Visualization application. This specialized tool offers an intuitive interface to visualize intracranial EEG data, both in the time and frequency domains. File scroll bar, a horizontal scroll bar allowing users to traverse through the EEG data file seamlessly. Play functionality, users can hit the play button to auto-scroll through the EEG data. The rate can be adjusted using the play speed control.
Yeah, we'll start developing in a second. We're currently on this EEG noise removal thing. Just in the project itself, move it up at the top. Just so it's clear what was updated last. This change is obviously not in production yet. So yes, that's the old thing that we had. We had some videos on it, but unfortunately it doesn't work anymore. That's why we are redoing this. It used to be LabVIEW, now it's Python, NumPy, SciPy, Pandas. And it kinda, yeah, it looks same but different. This is what it currently, this is what it's gonna look like. Hopefully we can publish it today so we can have something to play with. Yeah, just quickly checking. This is a bit weird, but yeah, this toggle button is nice. Levels. Right, you can barely see its effect. So yeah, if it's level, be able to go all the way down to 0. Yeah, so that's the original signal and the noisy one next to it. There's a kind of natural DC in it. So when you hit the trending, they're almost overlaid one on top of another. Yeah, you kind of see the noise there at the back. Some of these wavelets will be doing more than others. Yeah, there's not really much difference between them. These two things don't work. I get a 400 error at the server. We'll have to fix that. We'll probably have to describe properly, make a prompt, proper prompt, so we can actually fix it. Let's start populating. Yeah, let's start with the HTML file. Oops. Is this the same file? Right, that's the... No, that's okay. Can close that. So we have the HTML popped into ChatGPT. And we have that line that was working quite successful. This... No. Where is it? Yeah, confirm reading the code. Do not generate anything else. This bit is handy because normally it should respond with...
I've read the HTML code you provided. It appears to be a web page for visualizing EEG, electroencephalogram, data with various controls for data processing and visualization.
That's right. So thanks for confirming that. Then next, let's pop in the JavaScript and the same prompt, but just reading, not generating anything else. I've read the code, that's great. It's it feels like it is important in what order this is done. Let's do CSS as well. Confirm reading, don't generate anything else. I've read and understood. Okay, it's giving itself human-like properties, which is a bit odd, but whatever works. And the last snippet of code is the Python Flask application. Right. So this switch now. Ooh. Yeah, the switch does work. It's the number of levels. It's going all the way to 0. Default is 5. That's okay. Let's start with something simple. Change the trend into a toggle switch. It's GPT-4, yes, yes. Let's see if it understands the context. It does. That's not very helpful because you can't copy the code when you have before and after. But we have the trend and HTML. Do we? It's actually called the trend toggle. It's already a toggle. We're replacing the whole thing. I guess so. Right, now it doesn't have the label. What else in the...
In the Flask code you provide, you're already reading the trend parameter from the request, which will be true if the checkbox, now toggle switch, is checked and will be missing if it's not checked.
Right, so we're actually checking for the ID for it is the trend toggle. And not the trend. No, actually, it is the trend. How is it even working at all if the... Okay, ID was the trend. Yes, that's the same.
This means no change is required in the back-end code since you're already handling it correctly. Note, ensure that the CSS code for the toggle switch, which you previously provided, is included in the index, HTML file or any linked starsheet so the toggle switch will be styled correctly.
Okay, now the only problem. It's not actually working, I guess because of the name. Where's this name used in JavaScript? Yeah, it should be just the trend, is it? Right, now it's working. Yeah, just leave it as is. We just need the label. A checkbox, the trend switch. We have another switch. pen with the noise. That goes on top there. Have the trend as name. Right, that's working fine. Right, we wanted to later we'll rearrange the whole thing. Let's see, log. Log can be changed to a button. Don't like the drop downs. No, that can stay as is for now. Right. Okay, we're ready. If everything is working, we can publish this. Not sure how we. Let me know what you think. Are we ready to publish? I would say yes if everything is functioning. There's still a problem with that. Yeah, replace the chair. Let's go through this for a sec. The effect of the noise is not very clear, but is there, but not very clear. Okay, that's just the way it is. Effect of volume transfer was not clear. Can all spin buttons be replaced by spin buttons replaced by sliders? Checkboxes replaced by toggle switches. Oh, right. Forgot about this one. Let's pop this in. So we wanna Make sure signal to noise ratio SNR and mean square error are showing actual values.
To show the signal to noise ratio, SNR, and mean square error, MSE, for the EEG data, you need to calculate and return these values from the back end and then display them in the front end.
Here's how we do it.
Modify the get_data route to calculate and return the SNR and MSE values.
Okay, we're using
From sklearn, metrics import mean_squared_error.
Okay. Let's find how GitHub Copilot works. It's already imported mean square error, and from math it's trying to import square root. Well, we don't really need it, do we? Okay, now get that. What's this thing called anyway? Oops. This input will be called from the client side to get the data. Okay. Rest of the code is an calculation. Do I have anything as in at the moment? No. So at the end of this function, which is getting ridiculously long, so I suspect later will be really hard to troubleshoot if there are any problems. We're doing this bit.
Hash SNR calculation signal underscore power equals NP. Mean, original underscore EG underscore data asterisk asterisk 2, noise underscore power equals NP. Mean, original underscore EG underscore data, EG underscore data, asterisk asterisk 2, SNR equals 10 asterisk N. Hash MSE calculation MSE equals mean underscore squared underscore error, original underscore EG underscore data, EG underscore data. Hash prepare the response underscore data equals raw underscore signals, original underscore signal, denoised underscore signal, spectrums, SNR, MSE, MSE.
Right, so I have to, didn't tell us, but we need to replace it. We don't need this one anymore. SNR. Square root, is it? Okay. And the EG data. It's the filtered EG. So it should be legit. Oh yes, that's mean square error. That's okay, it's not getting much information. Can ask Copilot explain this? Yeah, using sklearn metrics to input arrays, the original and the filtered one. The mean squared error is a measure of the average of the squares of the errors. That is the average square difference between the estimated values and the actual values. Yeah, could be a better explanation. We might later get ChatGPT to explain it in a better way. Right. So let's see if it's actually works or not. We need also to change the front end. Well, in the front end, we already have the metric there. We need to make sure it's actually taking SNR, MSC, SNR, yes, MSC, yes. The capital. Wait. It's not called SNR output, is it? Doing it in a different way. Why? Again, HTML. Span ID is now value. Why is it different to that? ID MSC. Okay, in the in JavaScript, make sure we have it. Have some S and yeah, they call this an output. No, why not just call it SNR everywhere? SNR output. Get element by ID. This will so not work. Okay. Should be getting an error. Script not found, something not found. Yeah, it's not even showing the error. It's the name of this thing, isn't it? Okay, so in Python, it's called SNR response data, justify response data. Then where do we get the raw signals? Okay, so that should be just data raw signals. Spectrum should be the same data spectrum. As an output is actually not being used. Okay, what am I doing wrong? Two decimal places. Just assuming using. I'm not using jQuery. Why are you assuming I'm using jQuery? Uh, Using element by ID. Yes, that's right. You are correct. We're not using jQuery, just using vanilla, whatever you call it, vanilla JavaScript. Okay. Why do I need to do this anyway? It's inside. When that I can catch what's happening after when data. Yeah, now I'm confused. It's showing me the values. Get HTML. let's have an IT. Let me see, output, yeah, that's the same. Why am I not seeing the text? Let's get rid of that for a sec. Comment it all out. Right, we have the numbers. Our main thing is how to make sure everything fits the one screen. Violet noise is on by default. Yeah, that's the color bit. Yeah, we haven't broken the inputs into 3 parts yet. We did all this. Now, make sure fits into the screen. Can you actually do it, or is it too much to ask?
To ensure all content fits within the screen and provides a comfortable user experience, consider the following approaches. Responsive design. Use a responsive framework like Bootstrap, or apply media queries to ensure elements resize or reorganize based on screen size. Viewport. Set the viewport in the less than head greater than of your HTML to make sure your website scales correctly on all devices.
Yes, I already have that.
Overflow control. Use the CSS properties overflow X, hidden and overflow Y, auto to prevent horizontal scrolling and enable vertical scrolling if the content overflows the viewport height. Flexible grids. Use flexible grids that adjust based on the viewport size. This can be achieved with percentages or modern CSS like Flexbox and CSS Grid. Font size adjustments. Ensure text is legible on all screen sizes. You can use relative units like M, Rem, or viewport units VW, VH.
Okay, the other thing. Make sure look like outputs Okay, I need to give me like specific suggestion. Yeah, I don't know what's the regular screen size, but still doesn't fit. So it's okay for the text to be below, but everything else ideally will fit into one screen. And if it's not big enough, it should adjust the size of the charts. Can you do that? It also can be displayed side by side. I think I tried this before, but let's do it again. Just grab the whole panel. Pop it into how to improve layout, making sure all inputs and outputs fit into the screen. Yeah, hopefully it understands that yeah, the text can be below.
The provided image showcases a user interface, UI, with controls at the top, a waveform graph in the middle, and a frequency spectrum graph at the bottom. To improve the layout and ensure that all elements fit comfortably within the screen, consider the following suggestions. Reduce padding, margins. The space between the UI elements, especially at the top, can be reduced to provide more room for content.
No, I think that's okay.
Group related controls together in distinct sections. For instance, wavelet denoise, Dorbaches, and levels can be grouped under wavelet settings panel.
And that's interestingly, but that's only grouping the controls.
Similarly, channel number, window size, the trend, filter order, whole spectrum, frequency scale, and scroll can be grouped under another panel like signal settings.
We actually had a prompt for that. Yeah, it should be. Break the panel into 3 parts. File, wavelet. Yeah, to make that clearer. Okay, let's go with this.
Drop-down menus. If the number of options within a category grows, consider using drop-down menus. This is especially useful for selections like Dorbaches 1 if more wavelet types are added.
Yes, we're already doing that.
Vertical alignment. Instead of a horizontal layout for controls, consider stacking some controls vertically to use vertical space more efficiently, especially if the screen's width is limited.
Yeah, we generally want to have like an adaptive layout. Use adaptive layout. Yeah, that's right.
Adjust the height of the graphs based on their importance. If the frequency spectrum graph is secondary to the waveform graph, it can be displayed with a smaller height.
If the screen is wide enough, the EEG signal in the time domain and the frequency domain should be side by side. That's right. How did you know? That's I'm going to say that. Responsive design. Let's continue with this response from GPT-4.
Responsive design. Ensure that the UI adjusts itself based on the screen size. This is crucial for users with smaller screens or when the application is accessed on tablets or mobile devices.
Don't understand. Do I have to do it like manually, or can I just tell it like everything be adaptive and that's it? Why do I need to check the size of the screen or device
Use
type?
tabs. If certain settings or views are not always needed, consider using tabs to switch between different views or settings panels. This can help declutter the main view.
Yes, but also
Minimize use of borders. While borders help define boundaries, overusing them can create a cluttered look. Consider using subtle shadows or changes in background color to differentiate sections.
Okay, now it starts
Clear
giving
visual
some generic stuff.
Ensure that primary controls or information, like the graphs, are more prominent, while secondary controls can be less emphasized. This can be achieved through size, color, or typography. Opt for modern UI components. Modern sliders, toggles, and buttons can be more compact and visually appealing, helping to enhance the overall aesthetics while saving space.
That's could be an interesting one. This one is for you.
Feedback and testing. Lastly, collect feedback from actual users. They can provide insights on which controls they use most often, what information they need to see most prominently, and which elements can be minimized or grouped together.
Yeah, this is exactly where I need your help.
Remember, while optimizing space, it's essential to maintain clarity and ease of use. It's a balance between aesthetics, functionality, and user experience.
Feels like it forgot the actual code, or is it not generating any code because I told it not to? Okay. Yeah, can we do all four specific codes suggestions? Okay.
signal to noise ratio, SNR, and mean square error, MSE, at outputs, designate specific areas on the UI where these values will be displayed prominently. You might consider using read-only input boxes or labels with a different background color or a border to differentiate them as output values.
Okay. Take that. And nothing have changed. Output box. I don't think I have an output box, do I? Yeah, I'll change the colors later. Alright, we don't see the difference because it's an output. Suggesting to do this instead. Okay, let's see the box. There are no values in it. What am I doing wrong? Let's do F12 here, Control Shift C. Let's troubleshoot it straight from the browser. Okay, what is the text? Where is the text? Where's that color coming from? Okay, I don't know what's going on. I don't see the numbers. Let's check the HTML. Read only. This is okay, but the whole div can be an output box. does look better, but unfortunately I do not see the numbers. Okay, adaptive, let's move on.
Use CSS Flexbox or Grid to create flexible layouts that adapt to screen size.
Right, so this container it's CSS. And we already have it now. Now the whole question is, we have a secondary CSS. And this one does have a container display flex wrap. Yeah, so we can't really do it because we already have container features in the styling of the whole project, so we won't be changing it here.
You want the EEG signal in the time domain and the frequency domain to appear side by side on wider screens. You can use a media query to achieve this.
Right, so by default, stack the charts vertically for mobile devices. Yeah, let's try it out. Oops. Come on. Right. This should be definitely wider. That didn't work. Ah, oops. To do the whole... No, the chart is there. Okay, let's do the whole thing, just in case that's the problem. Okay, that doesn't work, obviously. What am I doing wrong? Do we even have the chart in? HTML? No, we do not. a call plot container. Right, because we need this.
Assuming you're using a charting library, you would add the chart containers in your HTML and use the above CSS to style them.
Download chart. And no, that's not what I use. I use this. You should have all the previous code. I'm not sure why you're giving general responses.
Given the provided HTML snippet and the requirements you mentioned earlier, you can modify and style the plots to fit responsively side by side on wider screens and stack on top of each other on narrow screens. Here's a suggested approach.
Right, so instead of we're using plot container.
Asterisk by default, set the plots to take the full width for narrow screens asterisk. Asterisk define a media query to style for wider screens asterisk.
Right. Pretty sure we're doing it instead of that. Okay. So in smaller screens, it will be like that. Larger screens will be plotted side by side, which is nice because we have everything fitting in and nicely. Let's see how it looks like on a mobile. What, iPhone 12 Pro? No, don't have money for that, so we won't be testing on it as well. It says Samsung Galaxy. Not sure which size I have. I can just check on multiple ones. It's not. No, I'm just trying to make sure it's not a tablet or anything. But yes, oop. Okay, what just happened? Yeah, on mobile doesn't fit really well. On larger screen it will appear like this side by side, so it should fit the entire screen. Yeah, this takes too much space, doesn't it? Let's restart. Right, so it does look much better. The errors we're having, yeah, no, they will be sorted in production. Yeah, the problem with smaller screen. Yeah, don't like it takes too much space. You can remove EG here. Just so it takes a bit less space. Yeah, those still don't really look like outputs.
The provided HTML is well structured, but to ensure our CSS works correctly, ensure the plots are within a parent container, which will help in managing the layout more effectively.
Yeah, okay, do I have this already? In HTML wrapper, no. It's not being used. So why do I need it?
The clear, both style in the last div ensures that any content below the plots will not wrap around them. This is a traditional method used after floating elements.
What's that?
The clear, both style in the last div ensures that any content below the plots will not wrap around them. This is a traditional method used after floating elements.
I don't know what does it mean, but I can try it out.
When the browser screen width is greater than 1024px, as specified in the media query, the two plots will be displayed side by side. For narrow screens, the plots will stack on top of each other. Adjust the 1024px threshold as needed based on your design requirements.
Okay, if you say so, I'll keep that number, because I don't have any better ideas. But what's up with... So we do have a plot container. Yeah, we don't have those titles. Have ID. So that's the same. Don't have any clearing anywhere, do we? No. Okay, so we have those two plot containers. Can replace the whole thing. This, let's save that as well. Yeah, this one's still not working. So yes, there's always more room for improvement. Yeah, let's assume the window size is not changing. Yeah, I don't know what to do on a smaller window size, it just doesn't fit. Yes, something will have to go. Labels could go. Yeah, that will be hard. Leave it for now. It's working okay. Yeah, just last thing, those things still. Let's try this again. Hopefully it doesn't get upset with me because I'm asking the same thing over and over again. Yeah, I'm trying those two outputs to actually look like outputs. Let's see. Yeah, so they change, okay. Wait, the trending should be on by default. The trend on by default. Let's fix the previous thing. Yeah, I want those two outputs to actually look like outputs. HTML adjust, two outputs is now, blah blah. And CSS, let's check. Yes, and right, so they just look like that. And let's change the, let's keep them both for now. Let's see if I'm actually, yeah, so those ones, where are the values? The values are not there. Anyway, hopefully it will appear on bodychaos.com later today. I have an extra tool to play with, provide feedback if you have time, and that would be awesome. Have to change the output container. No, oops, can't even copy paste properly. I have a plot container. Yeah, we don't have it. Label, no. Output, no. Main problem is that this SNR is not showing any values. That's the old one. Yeah, the new one looks more like an output. Then where are the values? They're just not there. What's that says?
The less than output greater than tag represents the result of a calculation and is semantically appropriate here. Pairing each with a less than label greater than ensures clarity.
What? Span ID. So I have the text, output ID. It's not being shown. Yeah, don't like all this fluff. Yeah, okay, maybe I did it. Get it. Where are the numbers? These two are not showing the actual values. What? The values are there. What's going on?
To ensure that the signal-to-noise ratio, SNR, and mean square error, MSE, outputs do not show their actual values by default, or until a particular action is performed. You can set the default values to a placeholder like, or any other string indicating that the value is not available or not calculated yet. This way, users know the values are pending or not available.
The values are there. Not sure what the problem is.
When you fetch or calculate the actual values for SNR and MSE, you can update the outputs. However, until then, they'll show. Until the updateSnRuncher function is called with actual values, the outputs will continue to display. This ensures that the placeholders are shown until you're ready to display the real values.
Yeah, I'm happy to do that, but that's not gonna solve the problem. No, like literally the numbers. Okay, can you regenerate it? Don't like this response. Why would you do that? Why would I do that? What did I say? Ah, made a mistake. Make sure showing the actual values. Sorry for that. Yeah, no, the values. Let's try again. So this one is working okay. However, is not showing the actual values. Ooh, get bogged down in these little things.
The less than output greater than tag is designed to display the result of a calculation, and you may need to set its value using JavaScript. If you have previously been using inner HTML or text content with a less than span greater than tag, you'll have to adjust the method to work with the less than output greater than tag. When you update the values of SNR and MSE in your JavaScript code, you should be doing something similar to. With the less than output greater than tag, you need to adjust this to. The difference is in using value instead of text content or inner HTML.
Okay, so just output. Okay, get element by ID.
If you prefer using the less than span greater than tag as it was working before, but want to keep the styling of the less than output greater than element, you can use a different tag, like a less than div greater than or less than span greater than, and style it to look like an output.
Okay, so will this work? And no, does not. Styled output. It's still not showing the value. Same thing. Works okay. This one doesn't work. Doesn't work as well. Troubleshooting.
Check if there is any CSS applied to output container, less than label greater than, less than output greater than, or styled output that could be hiding or misplacing the content. You can do this using browser developer tools, e.g., inspect element in Chrome.
And no, there's nothing affecting this thing. Oh, come on.
Ensure that there's no JavaScript that's inadvertently targeting and changing these elements. You can add a temporary inline event listener to log any changes.
Be sure it's not changing. The save span. Styled output. Comment all that out. Right. So maybe it was changing or something. Oh, yeah. Just get rid of all of that. So I think we're ready to publish. Might do it a bit later. Yeah, this should be an easy fix. That's working now. moving on. The trend on by default. It's suggesting to change HTML. It should be easy. Yeah, we'll continue this later on today. See you in a bit.